at MEP CAD Guru, one of the best institute near Guntur, Tenali, Vijayawada, Mangalagiri, Andhra Pradesh. 20 years of experience, faculty, quality education, value for money, 100% job oriented, 100% job assistance, lowest price, digital classes, site exposure, while learning, real life projects. Hands-on experience. The basic refrigeration cycle for beginners. If we are interested in learning how a refrigeration system works, it is helpful to understand from the pH, pressure enthalpy, chart perspective. It makes our life easier. This is how the refrigeration cycle diagram looks. Yeah, it seems complicated at first, but it will be easier to understand once I explain the refrigeration cycle diagram section by section. It is important to understand the basic refrigeration cycle. It helps us to comprehend what is going on within the air conditioner units. The refrigeration cycle tells us, if there is air in the air conditioner units, what to repair. After troubleshooting the refrigeration system, if there is enough air conditioner freon, or if the filter is dirty, we could know the entire thing by knowing the pressure and temperature of the evaporator, condenser, and compressor. Once we have found the pressure and temperature, we plot in the pH charts to determine what and where subcooled and superheat take place in the pH charts. Here is how pH charts looks. The pH chart graphically shows where the physical states of these four mechanical components is, and what is happening to the refrigerant within these components. However, first let's understand air conditioning theory, the basic principle, types of heat, how heat transfers, and we'll discuss how the basic refrigeration cycle diagram works. Air conditioning theory. There are two laws that are significant to understand the basic refrigeration cycle and air conditioning. Thermodynamics' first law explains that energy cannot be neither created nor destroyed, but can be changed from one form to another. Thermodynamics' second law can help us better understand how the basic refrigeration cycle works. One of these laws state that heat always flows from a material at a high temperature to a material at a low temperature. This is just the basic, by the way. If we are interested, we should take thermodynamic class. We'll learn all the equation and calculation behind it, as I have mentioned in the residential air conditioning section. Air conditioning, the refrigeration cycle, is a process that simply removes heat from an area that is not wanted and transfers that heat to an area that makes no difference. The air conditioner itself does not create heat. It just transfers heat. For heat to transfer, there has to be a temperature and pressure difference. In the refrigeration process there are two sections which produce a pressure difference, a high pressure, high temperature section, condenser, and a low pressure, low temperature section, evaporator. The refrigeration system removes heat from an area that is low pressure, low temperature, normally called evaporator, into an area of high pressure, high temperature, normally called condenser. For example, if cold refrigerant, 40 degree Fahrenheit, flows through the evaporator and the air surrounding evaporator is 75 degrees Fahrenheit, the cold 40 degrees Fahrenheit will absorb the heat from the 75 degrees Fahrenheit space. By absorbing the heat from the warm space, it also cools the space. It then transfers that heat to condenser, high side, through compressor. A hot refrigerant from the compressor flows to a cooler location, the condenser medium, air surround condenser. For example, the refrigerant will give up the hot vapor heat it absorbs from the indoor evaporator, and becomes cool again, and turns back to liquid. This is what the second thermodynamics law stated. Air conditioning is a way to keep our home comfortable by controlling the temperature, air movement, cleanliness, humidity, or dehumidify for our comfort. To move heat from the evaporator to the condenser we need refrigerant freon and other mechanical components such as compressor, condenser, expansion device, and evaporator. Therefore we need to understand how heat transfers between these components and with ambient. Basic refrigeration cycle principles. As refrigerant in the latent state, or as vapor refrigerant in the process of change state to liquid, this is the phase where it absorbs or ejects large quantities of heat. The quantities of heat absorbed or ejected can be managed by controlling the pressure and temperature of the refrigerant. The boiling point of closed system liquid can be controlled by changing the vapor pressure above it. Gauge pressure is used to determine the pressure inside the closed refrigeration cycle system. It's expressed in pounds per square inch gauge (PSIG). Heat flows from a material at a higher temperature to a material at low temperature. Heat energy is not created, but converted and transferred. What are two forms of heat, and where does it take place in basic refrigeration cycle? Sensible heat: when change in temperature can be measured by a thermometer, or when we put our hand on an object we'll feel heat. That is sensible heat. Latent heat absorbed or ejected, when a refrigerant is changing state from liquid to gas, or vice versa. However, the temperature remains the same. Heat is known to add to refrigerant, but does not register in a thermometer. It just changed the refrigerant state, gas to liquid, or vice versa. This is also known as hidden heat. I will start the basic refrigeration cycle diagram discussion on evaporator section first. As we remember, evaporator and condenser act as a heat exchangers in the air conditioning system. There are two pressure lines and two heat exchangers. The low pressure line is an evaporator. It absorbs heat, and the high pressure line is the condenser. It rejects heat. The first heat exchange that occurs in this basic refrigeration cycle is the evaporator. The air conditioner evaporator is located between point 6 and 1 in the basic refrigeration cycle diagram. The evaporator is a heat exchange that is responsible for absorbing heat from whatever place, medium, that needs to be cooled. For our discussion it's indoor. Do we remember thermodynamics' second law? This law states that heat always flows from a material at a high temperature to a material at a low temperature. Since the evaporator is at a low temperature than the air surrounding it, it will absorb the surrounding heat until the refrigerant liquid inside the evaporator coil starts boiling as a result of absorb that heat. As the evaporator refrigerant has boiled completely to vapor, it's now saturated vapor at 0.7. Some compressors cannot pump liquid. If it does pump liquid, it will damage it. This is why we need the entire liquid refrigerant to boil at 0.7. After, the entire liquid refrigerant turns to vapor and passes 0.7. Superheat occurs. Superheat is between 0.7 and 1. Superheat is life insurance for the compressor. It makes sure the compressor does not pull in liquid refrigerant from the evaporator. The air conditioner compressors located between points 1 and 2 has two important lines: a suction line, low side pressure or back pressure, and discharge pressure, high side pressure or head pressure. The suction line is the line that pulls the low pressure and temperature from the evaporator, and the discharge line is the line that compresses and pushes that superheat vapor to the condenser. It creates a pressure difference in the air conditioning system by pulling in low pressure, low temperature vapor from the evaporator suction line and increasing it to high pressure, high temperature superheat. This pressure difference what makes the refrigerant flow in a refrigeration cycle. The compressor is also known as the heart of the refrigeration system. The compressor is known as the vapor pump. The air conditioner condenser located between points 2 and 5 is a heat exchange. It rejects both sensible and latent heat absorbed by the indoor evaporator plus heat of compression from the compressor. There are 3 important states that take place in the condenser heat rejection. The first state points 2 and 3 are superheat, or simply rejects hot superheat vapor. It removes sensible heat. At points 3 and 4 this the state where it rejects saturated vapor's heat. It starts changing phase from vapor to liquid. As the refrigerant reaches point 4 it is 100% saturated liquid refrigerant. From points 4 and 5 it removes sensible heat from the saturated liquid refrigerant. This is where we could use a thermometer and tell how much heat it has removed. As more heat is removed it's now in the subcold region. The expansion device, or metering device, is normally installed in the liquid line between condenser and evaporator, points 5 and 7. For small units such as window AC, or split AC, vertical unit, we cannot see it, since the device is within a compartment. In a regular split central air conditioner system it is located indoors near the evaporator coils or chiller. The general principle behind any metering device is it acts as a restriction. We can see it in the diagram. It reduces high pressure, high temperature refrigerant from the condenser liquid line to low pressure, low temperature refrigerant for the evaporator. What causes the temperature reducing is due to the restriction. Refrigerant is allowed to pass through a small orifice. This makes a small part of refrigerant to evaporate and reduce temperature and pressure of balanced refrigerant. The refrigerant gas formed in this process is called flash gas. In a way this is non-effective refrigerant in evaporator. The metering device is responsible for providing the correct amount of refrigerant to the evaporator. The operation of a metering is more complicated. However, the restriction is the principle behind every metering device. In refrigeration system all the 4 major components such as compressor, condenser, evaporator, and expansion device must be balanced and selected properly as per design load normally called as tonnage of refrigeration, and all these components must be connected with suction line and discharge line with suitable material such as copper or mild steel etc.